to the first of two tutorials on percentages. Now this is a topic which is very much on the applied side of mathematics. What we're really doing is using a particular choice of fractions, namely hundredths, to essentially sort of quantify the change in things around us. Percentages are primarily used, I would say, really in politics and in economics. It's nearly always applied to financial aspects. They're used somewhat in science, but I would say less so than in, as I say, everyday life. You know, how much does someone's wages go up in a given year? What's inflation? Nearly always politicians' promises or their defense of their record involves telling you about the percentage change that they have managed to accomplish. Because percentages are used in politics and economics and so on, it is very good, I think, as a citizen to have a good grasp of percentages, because then you can judge quite accurately and quantitatively what you're being told. I think, unfortunately, there's often quite a lot of, let's say, mischief made by the powers that be in pulling the wool over people's eyes by quoting percentages in a rather odd way that, while strictly true, is not really terribly helpful and might be called disingenuous. So anyway, for our purposes though, what are percentages and what do we need to know about them? So I'll, in this first tutorial, define what we mean by percentage. I'll give some simple examples, and we'll just do some calculations of percentage increase and decrease. And then in the second tutorial, we'll cover two topics which are a little bit more advanced. One is the idea of an accumulation of percentage increases or decreases. In financial terms, that's often called compound, so compound interest, for example. And then we'll cover a topic that nearly everyone finds quite difficult, which is reverse percentages, where you're given the outcome of a percentage change and you have to work out what the original value or state of something was. So, percentage. Literally then, percent means 1/100th. So let's do some examples. So 50%, and we use this symbol here for percent, means 50 lots of 1/100th. And we have some good fractions practice here. So we can multiply these numbers together. So 50 times 1 is 50 all over 100. And then we have practice with looking for a common factor in the numerator and the denominator. I think it's pretty obvious here that the common factor is 50. So I can strike out the 50 to get 1 and strike out 50 in that 100 and be left with 2. So I'm thinking of that 100 as 50 times 2, striking out a 50 and being left with 2. So we see here that 50% corresponds to 1/2. So if someone's referring to 50% of something, they may as well be saying half of something. Okay, let's just do another example. Let's look at 10%. That's 10 lots of 100, which is 10 over 100. I can write 100 as 10 times 10, and I have a common factor of 10, and I'm left with 1/10. We can have percentages which are less than 1. So for example, you might see 0.1%. Well, that would be 0.1 lots of 100. And I think the best way to do this probably is to think of 0.1 as a tenth times 100th. We can use our fractions multiplication to see that that's 1,000th. So 0.1% is 1,000th. We haven't really talked much about decimal numbers in this series of tutorials to date, but we can convert these percentages to decimal numbers. The easiest way really is to look at the percentage and to move the decimal point 2 places to the left, because we're essentially dividing by 100. So 1/2 is 0.5, 10% being a tenth is 0.1, and 0.1%, 1,000th, would be 0.001. I'll be giving a tutorial shortly on scientific notation and significant figures, and I'll be speaking a bit more there about thinking about the decimal representation of numbers both large and small. Okay, so that's fine. Let's now just do some examples of the normal type. So let's say that someone has £100. Now, often one gives examples involving money. Because I'm in the UK, I'm using the British pound as the unit of currency. So if we have £100, we put in the bank, and let's be in fantasy land, shall we, and say that there's a good rate of interest, which isn't the case right now. Let's say after 1 year there's been an increase of 5%. So how much is now in the bank, in that account? In the bank account. Okay, well, we need to work out the amount of interest that's been earned, which is 5% of the original amount. So we want to know what 5% of 100 is. Well, 5% is 5/100ths, and we're multiplying that by £100. In this case, it's very straightforward. The 100ths are common factors on the top and bottom, they cancel, and we're left with £5, which is the amount of interest earned. So this, in addition to the original £100, is how much is in the bank account. So after 1 year, we have £105. Let's just do one more example. Let's imagine that someone buys a car for £2,000, and let's say that several years later they sell it, but the value has depreciated by 25%. So we want to know what the new value is. Now, depreciated means has gone down. So 25% of 2,000. So we have 25 over 100 is 25% of. Remember I said in the fractions tutorials that of in a maths problem nearly always indicates that you need to be multiplying. So it's 25% of 2,000. Let me do this carefully here. So this is 25 over 100. And just so that it's clear to you what's going on, let me split 2,000 into factors. I'm going to call it 20 times 100. And that way you can see that we have a common factor of 100 on the top and the bottom. And then I'm just left with 25 times 20, which is 500. So 25% of £2,000 is £500, and so the value has gone down by 500. So the new value is equal to £2,000 minus 500, namely £1,500. Okay, so this is the new value in the account there. So I hope those two simple examples are helpful. In the next tutorial, I will talk about, as I say, this accumulated interest year on year, or accumulated percentage, which we call compound interest, which we can also look at in terms of an accumulated deficit. And I'll also look at this rather slippery topic of reverse percentages, which I know causes everyone a bit of a headache. And I'll just show you the way that I like to approach those problems, which I think is quite clear. So I hope that's been helpful, and I'll see you next time.